let's have a look at question 3, okay? In question 3, guys, we are basically given a bookshelf, right? And with this bookshelf that is given, certain dimensions are unknown. As you can see here, this dimension is unknown, and this dimension is also unknown, right? So we basically now have to work with the information that is given to us to help us determine now these unknown dimensions. All right. So with question 3, I did mention that question 3 deals with measurements as well as packaging. Okay, so let's get started. It says TD needs a bookshelf to store her files. She decides to buy a second-hand wooden bookshelf with 2 shelves as illustrated below. So she buys a bookshelf, and this bookshelf basically has 2 shelves, the top shelf as well as the bottom shelves, right? We're given the dimensions, right? We're told that the inside width, okay, is 162 centimeters, right? And then we are told that the total outside height is 80 centimeters. So that is our outside height. We are told the inside height of the bottom shelf is 40 centimeters. So that is our inside height, right? We are also told to note the area of a rectangle is equal to your length times width. So at this point, guys, we're happy because they gave us information how you calculate the area. We are given the dimensions, right? And all that we need to do now is we need to now use the information that is given to us here to answer the given question. Let's see. Question 3.1 says the top shelf has a thickness of 1.5 centimeters all around. Okay, so we've got our top shelf here, and we're told now that this top shelf, right? Okay, that is our top shelf, right? There's that thickness here. Okay, that thickness is 1.5 centimeters, and they're saying it's all around. So that thickness there as well is also 1.5 centimeters. Okay, that thickness is 1.5 centimeters. Okay, that thickness is 1.5 centimeters. Okay, that thickness is 1.5 centimeters. So we are told that the thickness all around is 1.5 centimeters. So we're going to just be focusing on the thickness that I've basically highlighted in yellow. And we're told that that thickness all around is 1.5 centimeters. Question 3.1.1 says, determine A, right, the outside length of the bookshelf. How would we then determine the outside length of the bookshelf, right? So just to help you guys see what is actually going on here, I'm going to do this for you guys. Okay, we already know what the inner length of our bookshelf is, right? The inside width, right, or length. I don't know why they said the width, but the inside length of our bookshelf. We know what it is, meaning that, I mean, it stays the same. That the inside length is constant at the bottom shelf and the top. So that means that the inside length as well for the top shelf is 162 centimeters. Okay. However, the inside length is not the total length of our bookshelf. It's not A. So how would we basically get A? We need to take into consideration the thickness of this bookshelf, right? So just to help you guys see what is happening here, we've got our bookshelf here, right? That is our bookshelf. Then our bookshelf has a thickness there, right? And we are only given the inside length, right? We're given the length from the inner length, right? And that inner length is 162 centimeters, okay? This is A, okay? The total length of our bookshelf. That is what we're trying to figure out, okay? How will we get that A? Remember, we were told that the thickness around our bookshelf is 1.5 centimeters. So that thickness there is 1.5. That thickness there is 1.5, right? And what do we see? Okay, for us to get A, right, what do we need to do? You basically add. A is basically equal to this 1.5 centimeters plus 162 centimeters. Okay, plus that inner length plus this 1.5 centimeters, okay, right? So that basically leaves us with A. Okay, so 1.5 plus 162 plus 1.5 gives us 165 centimeters. Okay, so the length of our A is 165 centimeters. Okay, remember guys, once you've basically determined the unknown values, also just plug them in, okay, so that you guys know what you've already calculated. So A is equal to 165 centimeters. Right, let's have a look at question 3.1.2. For question 3.1.2, it says the base of the bottom shelf is 4.5 centimeters thick. You can see that this base, guys, right, it does not have the same thickness as the thickness of the top part there. Okay, you can see. So we are told that this base here, right, the thickness is actually 4.5 from there to there, because that has its own base, right? There, from there to there, that is our base. Okay, and we told that that base, right, the thickness, right, for the distance from there to there is 4.5 centimeters. Okay, right? So now determine B, the inside height of the top shelf. So how would we be able to determine B, right? So here we just basically move from the bottom to the top. We already know that the thickness from there to there, that thickness there is given as 4.5 centimeters, right? Then we know that the distance from here to here, from the base going to just before that thickness there, is equal to 40, because the inner length, right, we told that it's 40 centimeters. Then remember here, we were told that that thickness for your top shelf is 1.5 centimeters all around. Okay, so we need to take into consideration that as well. It's not 4.5, it's 1.5, that thickness there. Then we are given B. Then we have that thickness again, which is still 1.5 there. Okay, so we see that, okay, for us to basically determine B, we need to take into consideration the thickness, because the thickness are different. Okay, but we already know that the total height of this shelf is 80 centimeters. Okay, so that's going to be our starting point. We already know that. Okay, for question 3.1.2, we already know that the total height is actually equal to 80 centimeters. That is the total height of the shelf. Okay, and this 80 centimeters is composed of this 40.5 plus the 40 centimeters plus the 1.5 plus B plus 1.5. Okay, so we're gonna add up all those values together. Okay, so we can even just say, okay, that 4.5 centimeters, right, plus 40 centimeters, that inner length, plus 1.5, that thickness, okay, plus that inner length of B, plus that 1.5 centimeters is equal to the total height of the bookshelf, which is 80 centimeters. Right, and all that we need to do now is we need to solve this equation for B by obviously collecting like terms, right? So we're just going to take the 4.5 plus your 40 centimeters plus 1.5 plus 1.5. What does that give us? If you add up all those values, you'll find that you get 47.5 centimeters plus B, right, is equal to 80 centimeters. All that we need to do now, we want to isolate our B. We want our B to be on its own. And to isolate our B, what do we need to do? We need to minus 47.5 centimeters. What you do on the left, you need to do on the right. So you're going to minus 47.5 centimeters. Therefore, our B is going to be equal to your 80 minus 47.5, which is equal to 32.5 centimeters. That is the value of what? Our B. All right. Cool stuff. So we've basically completed question 3.1.2. Let's have a look at question 3.2. In question 3.2, it says the total outside height of the bookshelf is equal to 31.496 inches, right? So that means that this height in inches, okay, is 31.496 inches, right? All right. So now they say determine rounded to two decimal places the conversion factor for the height in the form of 1 inch is equal to something centimeters. So how do we basically determine the conversion factor? So yeah, guys, we're going to use what we know as our starting point. We already know that the 80 centimeters height, right, is the same as 31.496 inches, because that 31.496 inches represents the height, or the outside height, right, in inches. So these values are basically the same. So we're going to use that as our starting point, right? That for question 3.2, right? Okay, we already know that, okay, the inches of 31.496 inches, okay, this height is equal to the height of 80, that height of 80 centimeters. It's just that our units are different, okay, but the height it's the same, okay. Both of these basically represent this height there. Okay, but remember, they're saying that now you need to write down the conversion factor, right, in terms of 1 unit is to something centimeters. So we've already started this, but however, we want it to be in the form of 1 unit is to something centimeters. So we need to divide now this 31.496 by 31.496 inches, okay? Not inches, just 39.496. So we are going to divide by 31.496. We're not dividing by inches because we're not trying to cancel out the inches on the left-hand side, right? So we're going to do the same. What you do on the right, guys, you need to do on the left. By 31.496. What you do on the right, what you do on the left, you need to do on the right. Okay, 31.496. What do we see? The 31.496 divided by 31.496 will give you your answers in. You'll just have 1 inch, okay, is equal to 80 divided by 31.496 is equal to 2.54. Then you've got 3 zeros. Then you've got 508 when you punch that into your calculator, right? So remember, they say round to 2 decimal places. We've got our answer here in more than 2 decimal places. Therefore, our final answer will just be 1 inch is therefore equal to, why did I write inchy? Inch. Okay, 1 inch is therefore equal to, rounded off to 2 decimal places, 2.54 centimeters. Guys, here you need to basically take into consideration, you want to have these inches here. That is why we're not dividing by the unit inches. Okay, we're just dividing by 31.496. Okay, and that is basically what that question was asking from us. Okay, that is your final answer. Okay, then question 3.3. It says that TD bought the bookshelf at a discounted price because the backboard, which covers the the entire width and height of the bookshelf needed painting. She decides to do the following. So she buys this bookshelf at a discounted price. And the reason why the bookshelf was discounted was because, I mean, this bookshelf still needs a bit of work. Okay, she still needs to paint the backboard. Okay, and we need to now basically read the following. She needs to remove the backboard, okay? So the board that is at the back of our bookshelf, she needs to now remove that board, okay? And then she's gonna paint the back of the board with a single coat of paint, okay? So guys, here you need to take into consideration, you know, when you have a board, right? Your board has the front side, it has a back side, okay? They tell us that when to paint the back side of the board, she just needs to paint it with a single coat of paint, right? And then to paint the front part of the board, she needs to paint it with two coats of paint, okay? So we need to take this information into consideration when we now moving forward. Okay, they say nail the backboard to the bookshelf, and then obviously when you're done painting, then you need to just ukokote there and then put it back together. Okay, so question 3.3.1 says calculate in centimeters squared the area of one side of the backboard. Okay, how would you calculate the area of this backboard? Okay, so here I'm gonna basically draw this for you. Okay, and thank you so much to all the learners that keep engaging in the video tutorials. I see you guys, like I've got regular learners that are constantly like, you know, commenting, and yeah, even with this paper, like I was pushed, you know, by the learners that are constantly commenting to upload this video tutorial. Okay, so thank you so much to all the learners that are constantly commenting. You guys really just make everything worth it. And also thank you to the silent learners as well, the ones that are just liking, you know. Thank you so much for engaging with the video tutorial. I really appreciate it, right? And I see all the comments, guys. I promise you I see the comments and I respond all the time, right? So thank you so much, guys. Thank you for supporting the channel. Please don't forget, at this point, if you're not subscribed to this channel, we are roba, guys. You are robbing me. Okay, please make sure that you are subscribed to the channel. Okay, if you have made it this far, and also please make sure that you like this video tutorial. Also, please share this channel with your friends, guys. A lot of learners are struggling in our country with mathematical literacy, with mathematics. Please share this channel with your friends. I'm also going to be doing more pure maths content, even if you've got pure maths friends. Okay, please share this channel with them. I've got some great Euclidean geometry videos that they can watch, and some paper one video tutorials that they can also watch. Please, guys, share the video with your friends. Please don't be stingy with information. You sharing the channel with your friends also helps me out a lot. Okay, so please share this channel with your friends. Okay, so let's get back to the video tutorial. So here we want to basically calculate the area of the back of the board. I'm just going to draw this board for you guys so that it basically brings everything into perspective. Okay, so that is a board. Obviously it's a rectangle, so I'm going to make it a bit longer. Okay, how do we calculate area? Okay, remember guys, when we're calculating area, we're dealing with a flat surface. Okay, so in this case, we just need the dimension for the width, we just need the dimension for the length, right? So in this case, we need the outer dimensions. Okay, we already know that the height is just equal to 80 centimeters, so we know that the distance from there to there is just equal to 80 centimeters, right? And then what do we know about the length, right? The length, remember the A, we calculated as 165 centimeters. So that is why I said put all the values that you've calculated on your image, on your diagram drawing, so that you'll know now, but okay, I already have this, and makes your life easier. Okay, so we already know that now this length from there to there is just equal to 165 centimeters. You're gonna put that in. Okay, then how do we calculate the area of a rectangle. Remember, guys, they gave us the formula here. So to calculate the area of your rectangle, also area of your R, it's basically just going to be length times the width, right? What is the length? It's 165 centimeters, okay? What is the width? The width is 80 centimeters, right? So if you punch that into your calculator, you will see that the area of this backboard, okay, we've basically calculated the area of the backboard, okay, and the area of the backboard, right, is equal to, when you punch into your calculator, 132 13,200 centimeters squared, right? We've got 2 centimeters there, so centimeter times centimeter is centimeter squared. Okay, so that is now the area of one side of the backboard. Okay, that's just the area that is covered by just one side of the blackboard. Okay, that is just what we've now calculated there. Okay, so now it says convert the answer in question 3.3.1. So this answer that we've just obtained now, 2 meters squared. So now how would we convert these centimeters squared into meters squared? So this is question 3.3.2. Okay, right. So remember, guys, we're gonna still use this concept of kilometers, meters, centimeters, and millimeters, right? And I already mentioned to go from a bigger unit to a smaller unit, we multiply. So we multiply by 1,000, we multiply by 100 here because we're moving from millimeters to centimeters, and you multiply by 10 here. To move from a smaller unit to a bigger unit, you divide. So you're going to do the inverse operation of what we did at the top. Divide by 10, divide by 100, sorry, and divide by 1,000. Okay, so now we're gonna add another element to this. Okay, we are basically trying to now convert centimeters squared to meters squared. So we are still moving from centimeters to meters, but then in this case we want to move, we're dealing with units for area. Okay, so in this case we want to move from kilometers squared, meters squared, centimeters squared, millimeters squared, right? So now what is happening? We also need to square these values. So it's going to be 1,000 squared, 100 squared, 10 squared, right? 10 squared, 100 squared, 1,000 squared. Okay, so now when we're moving from your centimeters to your meters, right, we're still doing the same thing. We are going to be dividing, but not by 100, but by 100 squared. Okay, so in this case, what are we going to do? You're going to take your value of 13,000. Okay, I'm going to take that 13,200 centimeters squared, and you're going to divide it by 100 squared. Okay, so if you do that, we'll be converting your centimeters squared, right? So if you punch that into your calculator, your 13,200 divided by 100 squared, you'll get that now your answer, or the area in meters squared, is actually equal to 1.32 meters squared. Okay, so that is basically how we do the conversion. All right, and we are basically done with question 3.1 all the way up until question 3.2. All right, let's have a look at the next page. Okay, question 3.3, it says 1 liter of paint covers an area, okay? So when you see that meter square, that means that we're talking about area. So 1 liter covers an area of 6.9 meters squared, right? Determine, rounded to 2 decimal places, the number of liters of paint required to paint the backboard completely. Okay, so here, guys, you need to be very careful. Okay, here we need to be very careful. We need to use the information that was given to us in the previous page to help us basically navigate this question. Remember, we had already calculated, remember, the area of our backboard, and we were also given information about the paint needed to cover the front side of our backboard, and the paint that is needed to cover the back of our backboard, right? Remember, they said that you need one. Okay, let's just do this. Let's not be fast. Okay, so remember, we've already calculated the area, okay, of this backboard, right? And then we saw that, okay, the area of our backboard, right, of the front and the back, okay, guys, the area, let's just do this so that you see the area of the front is equal to the area of the back, okay, guys, because the shape is still the same, it's still the same flat shape. Okay, so then the area of the front and the back, right? When you're talking about area, we're talking about this whole region there. Okay, so the area of the front is equal to 1.32 meters squared. The area of the back is still the same, 1.32 meters squared. Remember, we were also given information here, right, that told us that to paint the bag, you just need 1 coat of paint. So for the bag, right, you will need 1 coat of paint, right? Okay, and for the front, we will need 2 coats of paint. Okay, right, so that is, we are building this question. Okay, and we are also told 1 liter of paint, right, covers. So now we know that, okay, 1 liter of paint will cover 6.9 meters squared. Okay, determine, rounded to 2 decimal places, the number of liters of paint required to paint this backboard. So now we're going to basically start off by determining how many liters of paint will we need for the back part of our backboard. How many liters of paint will we need for the front part of our backboard? Okay, then we're going to add these 2 liters together to determine, rounded to 2 decimal places, right, the number of liters that are actually required. Okay, so that is basically what we're going to do. Okay, this is question 3.3.3. Okay, so we're going to start with the back, right? Okay, so for us to be able to determine how many liters we'll need, right, we're going to work with this area. We know that for the back, right, we basically need, the back has an area of 1.32 meters squared. Okay, so we already know that the area of the back, right, is equal to 1.32 meters squared. Then we're going to work with this equation that is given to us here. This equation here, we're going to work with it, and this is going to help us determine how many liters of paint will we need just to paint 1 coat for the back. All right, so we're going to take that 1.32 meters squared. You multiply by what you want. Okay, what do you want? We want to determine how many liters of paint do we need. So we're going to multiply by 1 liters divided by what you have. You've got your units in meters squared, so it's going to be 6.9 meters squared. So here, right, you should see that the units, your units for meter squared and your units for meter squared should cancel for you to just have your answer in units of liters. All right, so if you take 1.32, this is just the same as saying 1.32 divided by, so 1.32 liters divided by 6.9, right? And then if you punch that into your calculator, you will get that, okay, to actually paint one quote of the back, right, you actually need 0.191,304,3478 liters just to paint the back of the board. Okay, and then we're not done. Okay, we still need to determine how many liters we will need to paint the front. Okay, so here to paint the front, okay, you will basically just take, still the area is still the same, okay, of 1.32 meters squared multiplied by, right? We're going to multiply it by what you want. We're still using this equation, 1 liter divided by what you have, which is 6.9, and you should still get the same answer, guys. It's still the same answer of 0.191,304 3478 liters, right? However, guys, remember when you're painting now the front, you need 2 coats. This basically shows us the liters that we'll just need for 1 coat. Okay, so now to determine how many liters we'll need for 2 coats for the front, right, it's us just basically taking this and you're multiplying by 2. Okay, right? Because if it's painting it twice, that's us just basically, this. Let me just show you guys. If you're painting first, remember when you're painting it the first time around, right? Remember you're painting the first time. When you're painting the first time around, the first coat, you're painting an area of 1.32 meters squared. Then you go again and you're painting this again. So that's the same as you painting an area of 1.32 meters squared multiplied by 2. Okay, so it's like us painting your this area twice. Okay, so that is why you basically need to multiply by 2. Or you can also just look at it from this from this perspective, where you just take this area. Remember, we said that the front part, we are painting it twice, right? It needs 2 coats. Okay, so it is basically going to be that area of 1.332, right, meters squared multiplied by 2. So that means that for the front part, we're going to be dealing with an area of 1.32 multiplied by 2, which is 2.64 meters squared. That is the area that we are basically painting because we are painting 2 coats. Then from there, we're going to convert now this to how many liters of paint you would then need to paint this area, right? So you're going to take that 2.64 meters squared multiplied by what you want. We're going to use this equation of 1 liter divided by what you have, which is your units in meters squared, right? Your units should cancel because we want our units in liters. So that's a way for us to basically check that they're canceling. So if you take 2.64 and you divide by 6.9, you will get 0.3826086957. So that is how much paint you would need to now paint the front. So now we're not done. All that we need to do now to determine how much paint we will need, we're just going to add the paint that is needed for the back part of our board plus the number of liters that you'll need, number of liters of paint we'll need for the front part, and therefore we are basically done. Okay, so we're going to take therefore the total. Okay, remember guys, we're trying to get the number of liters of paint that is required, right? So therefore the total liters, okay, total liters needed or required is equal to, we're going to add these 2 values, right? It's going to be that 0.191,304,3478 liters plus 0.382608 6957 liters. If you punch this into your calculator, let me just move it like this because I'm like trying to cramp everything in. If you punch this into your calculator, you'll find then that your total liters needed is actually equal to 0.573 9130435 liters. But remember, what was the question saying? Determine, round it to two decimal places. So we need to round off this answer to two decimal places. So that is approximately 0.57 liters that will be needed for TD to basically paint her backboard. Okay, so that is it. Remember, guys, I don't only round off the final answer, right? Just to maintain accuracy so that we are all on the same page. Okay, so that is how much will be needed. I hope I clarified that for you guys. Let us have a look at question 3.3.4. Okay, it says TD stated that one 500 milliliter can of paint is sufficient, or it is enough, right? To paint the backboard completely. Okay, I need to verify with calculations whether her statement is correct. Okay, so here, guys, all that we need to do this question, we basically want to convert this these milliliters into liters, and then we need to basically determine if her statement is valid. But from here, it's very easy, guys. We already know how we are supposed to convert from milliliters to meters, okay? Because we know, this is question 3.3.4, okay? We already know that 1 liter, okay? 1 liter is equal to 1,000 milliliters. Okay, so we're gonna convert these liters that are given, that we've already calculated, right? Because we know that, or she needs 0.57 liters of paint. Okay, so we're gonna convert these liters into milliliters, right? And then from there, guys, we can already see that her statement is not true. Okay, but let's just continue, right? So from here, we're going to convert these liters of paint that we've calculated that she needs. So we're going to take that 0.57 liters. Then we're going to use this equation to help us convert, okay? So here, we're going to use this equation to help us convert, all right? So from here, how do we convert? You multiply by what we want. Remember, we want our units in milliliters, so we can compare these two values properly, okay? So you're going to multiply by 1,000 millimeters. Then you're going to divide by the units that you have. We've got units in liters, okay? Here we see that they cancel. And then if you take 0.5 and you multiply it with 1,000, you will see that 0.57 multiplied by 1,000, you will see that you actually get 570 milliliters. So what do we see now? She is basically saying that she just needs one 500 milliliter can of paint, right? And she's saying it's going to be efficient. But however, what are we seeing here? It's not going to be efficient because she's going to need 570 milliliters of paint. Okay, so here we can basically confirm that her statement is not valid. Okay, so her statement is not valid. She will need. All right, and we are basically done with question 3.3.4. All right, yeah. So now we're going to have a look at question 3. I'm going to do this one on the next page, right? And question 3.4, guys, basically deals with packaging. Okay, so we're going to use all the concepts that we've learned from packaging. So please make sure that you pay attention. So what is happening here? Okay, so here in question 3.4, we are told that TD wants to organize her documents in files. She was informed that you can store files separately, okay, single files, or in a filing box as shown in the picture below. Okay, so the picture of a filing box, so you can basically store your files in a box, or you can store them like individually. Okay, we are told that a single file has a width of 8.1 centimeters, right? And we are told that the width of the filing box, right? So the width of the box, this is the width of the box from there to there is so 345 millimeters. Okay, and then the width of a single file we are given there is 8.1 centimeters. Okay, so it says use the information above to answer the questions as follows. Question 3.4.1 says determine the maximum number of filing boxes that could fit on one shelf, which is 162 centimeters wide. Okay, so here we are told that basically a shelf is equal to, or a shelf, right, is 162 meters wide. Okay, so it is 162 meters wide. Okay, and now we want to basically determine how many number of filing boxes, yeah, can we fit on this one shelf. All right, so here we already know that, okay, the filing boxes, right, the width that is given here is actually 345 millimeters. Okay, so for us to be able to basically do our comparisons properly, that means that we first need to convert these this width of the shelf, right, from centimeters to millimeters. Okay, how do we do that, guys? If you want to move from centimeters to millimeters, all that we're going to do is to move from centimeters to millimeters, we multiply by 10. Okay, so we're going to multiply by 10. Okay, so we're gonna just take that 162 centimeters, and you're gonna multiply it by 10 to just basically have the width of this bookshelf in millimeters. Okay, so if you multiply it by 10, then you'll see that the width is actually equal to 1620 millimeters. So the width is equal to 1620 millimeters. So from here, we can basically now compare properly how many filing boxes we can fit here. Okay, so for example, let's say we already know that one filing box, the length is 345, right? So if the length is 345 for one, right, how many can we fit into this bookshelf? Let's say one is 345, the other one is 345, the other one is 300. How many 345 millimeters can we fit into 1620 millimeters? Okay, so we already know that one box, right here, we already know that one box, right, is equal to 345 millimeters. That is the length of one box. But we want to basically determine how many boxes we can now fit into this bookshelf. Okay, so we're going to take that value of 1620, and then we're going to use this to help us now determine how many boxes we can fit into our bookshelf, right? So we're going to take 1620 millimeters. You're going to multiply it by, we want to determine how many boxes, right? One box, and then divided by, okay, what we have, which is our units in millimeters. Okay, so it's going to be 345 millimeters. Okay, what do we see here, right? If you basically punch this into your calculator, you can punch it in as 1620. Remember, the meters and the meters cancel. That is whatever value that we'll get basically tells us how many boxes we will need, right? So it's divided by 345, right? And if you punch it into your calculator, you will get that you will actually need fit in 4.69562 boxes. That's the total number of boxes you will be able to fit into this bookshelf. However, guys, you can't now, I mean, we want to be able to fit in a full box. Okay, we don't want to be fitting in like cut out boxes, right? So you want to be able to fit in a full box, right? And in that case, that means that now we are going to now, because you can't fit in a full 5 boxes here, guys, you're not just gonna round off and be like, oh, that means that I'm gonna be able to fit in 5 boxes. No, okay, that means that if you say you're gonna fit in 5 boxes, you're gonna go over your limit there, okay? But in this case, we are just going to now round down. Okay, so in this case, that basically means that we can only fit in 4 boxes. Okay, so that means that you'll be able to fit in like let me just show you guys. Okay, you'll be able to fit in 1 box, right? Another box, 2, another box, 3. Okay, show you 1, 2, 3, 4 boxes, right? Then there'll be like a bit of space left there. So you can only fit in 4 boxes, okay? We can't say you can fit in 5 boxes, because if we had to fit in 5 boxes, it would go over. Do you see that? So in that case, we can only just fit in the 4 boxes, okay? Our dimensions only allow us to fit in 4 boxes because we're not cutting boxes. You can't just invisibly go through this bookshelf, so you can only fit in 4 boxes. So I hope I basically clarified why you need to round down there. Okay, and that is that for this question. All right, let us have a look at the next question. Question number 3.4.2. Calculate the difference in the number of files that she can place on one shelf if she packs the shelf with single files rather than filing boxes. Okay, so in this question now, they want us to compare or get the difference of the number of files that she can place on one shelf if she packs the shelf with single files rather than with boxes. We already determined that if she decides to pack with boxes, she can only fit in 4 boxes. Okay, remember we said that she can only fit in 4 boxes. So this is the first box. Okay, this is the first box, this is the second box, this is the third box, and this is the fourth box. Okay, all right. And then this question basically wants us to look at this from 2 sides, right? This is 3 point, sorry, I forgot to label this one accordingly. This is question 3.4.1. Okay, now we're doing question 3.4.2. So with question 3.4.2, right, we are basically going to compare 2 values, right? How many boxes or how many files can she fit if she basically decides to pack the files in the boxes? So if she wants to pack in boxes, how many files can she put into the shelf? And then if she wants to pack individually, so if she wants to pack the files individually, right, not putting them in the boxes, how many files can she fit into the bookshelf? Okay, so here with the first part, we've already calculated, right? We already know that we can only fit in 4 boxes. And in the 4 boxes, how many files can fit into that box? Okay, we were given information here, right, that one file can only take 1, 2, 3, 4. I mean, one box can only take 1, 2, 3, 4 files. Okay, so this one box can only take 1, 2, 3, 4 files, right? So for us to be able to determine how many files then would we be able to pack when we are packing with boxes, what do we need to do? We're going to take these 4 boxes and you're going to multiply by the 4 files in each box. Okay. All right. So here we see that if we decide to pack in the boxes, right, or pack our files using boxes, we can only pack 16 files. Okay. So now what happens if we decide that now we don't want to pack our files using boxes, but you want to pack them individually, right? Remember, we're going to go back to this drawing here. We already know that this whole shelf is 1620 millimeters long. Okay, so if one file, remember here we were given the file is equal to 81 centimeters, how many files can we now fit into this shelf? So if one file is 81 centimeters, how many files can we now pack into this shelf, taking into consideration the length of one file? Okay, so before we can even compare here, we still do the same thing. We have to convert that 8.1 centimeters into millimeters, so we will be able to work with the same units. Okay, so we're going to take that 8.1 centimeters and we want to convert it into millimeters. We're going to go back to our drawing here that helps us convert from centimeters to millimeters. When we're going from centimeters to millimeters, you multiply by 10. Okay, so we're going to multiply this value by 10. Okay, we're going to take that 8.1 centimeters and you're going to multiply it by 10. And then if you multiply it by 10, you will see that, oh, okay, the length of or the width of one of the files is actually equal to 81 millimeters. Okay, it is actually equal to 81 millimeters. So since now we know that, okay, the length or the the width from there to there is 81 millimeters. How many 81 millimeters can we now fit into this bookshelf? Okay, so here we already know here that one file, right, is equal to 81 millimeters. Okay, so we're going to use now this to help us determine how many files now can we fit into this bookshelf. We're trying to determine the files that we need. Okay, so we're going to still take the length of our bookshelf of 1600 millimeters, right? And then we are going to multiply by what you want. You're going to divide by what you have. Okay, so in this case, you multiply by what you want. You want to determine how many files can we fit. So you're going to multiply by one file because we want to determine the units in files, divided by 81 millimeters. Okay, so here if you punch this into your calculator, 1620 divided by 81 is equal to 20 files. That means that, okay, if we had to now pack these files individually, do you see that we'll be able to actually fit in more? We actually can fit in 20 files if we had to now pack them individually, more than what we could fit in if we decided to use the box. But now the question is asking us to calculate the difference in the number of files that she can place on the shelf if she packs with the single files rather than the filing boxes. So we're comparing the value that we got from the boxes to the value that we get from the files. Okay, so we're going to basically just take the 20 files because we want the difference. Alrighty, difference, they basically saying that we are subtracting, so the difference, right, will be equal to 20 files minus 16 files, which is equal to 4 files. Okay, that is the difference that of the number of files that she can basically place. Okay, let us have a look at question 3.4.3. It says calculate a possible reason why TD would prefer the the filing boxes. So we can already see that, I mean, she'll be able to pack more files, okay, if she decides to pack these files individually. But why would she then prefer to use the boxes? Okay, here guys, you just need to think of it logically. Why would she prefer the boxes? Maybe the boxes, I mean, the boxes could make her file look neater, okay? Or it'll be easier when she basically maybe uses the boxes. It's easier to then separate the files, maybe according to, maybe let's say you're a person and you want to file different files for mathematics, and you want to have these files are for all my mathematics work, and these are the files for all my English work, where maybe how I do drama, here I do poetry, here I do literature, and stuff like that. So you'll find that maybe she decides to use the boxes because it's easier for her to separate them, or maybe it's neater with the boxes. Okay, so any of those reasons will be accepted. Okay, so you can just say it's a neater storage, or that it will be easier to separate the files accordingly. Any of those ones will be accepted. Okay, let us have a look at the last question. Question 3.4.4 says TD bought filing boxes to pack the top shelf separately. Okay, she could not remember in which file she placed a document. She randomly chooses one of the files out of the filing boxes, determined as a percentage to two decimal places the probability that the file she chooses will contain the documents that she is looking for. Okay, so here we can already see that obviously this is a probability question. So we're going to use that probability is equal to favorable outcome over your total outcomes, right? And then here, okay, we are told that she obviously randomly chooses one of the files, right, out of the filing boxes, right? So that's basically gonna give us information about our favorable outcome and our total outcome, right? The favorable outcome, she says she basically chooses one file out of the filing boxes, right? So our favorable outcome, I mean, our out of the filing boxes, we need to determine as a percentage to two decimal places the probability that the file she chose, right, that one file that she chose, that is the favorable outcome, right, contains the document that she is looking for. Okay, so here guys, nice and simple. Okay, I did mention that this is a probability question. So question 3.4.4, right, is equal to, this is probability, right? Probability is equal to your favorable outcomes, okay, divided by total outcomes. Okay, and then we already know that the favorable outcomes, she just wants to take out one file. Okay, that is one divided by the total outcome. So how many total files is she taking out that one file from? Here guys, you're not going to say it's 20. Okay, why not? Because they've basically mentioned that she's taking it out from the filing boxes, right? So when we dealt with the filing boxes, we already calculated she can only fit in 16 files when we're dealing with the filing boxes. So that is why we now divide by your 16. Okay, but because this question wants you to get your answer as a percentage, you need to also remember that you need to multiply by 100. Okay, so if you then take 1 divided by 16 and you multiply by 100, you will then get that, okay, the probability that it's the file that she wants is actually going to be equal to 1 divided by 16 times 100 is just equal to 6.25%. Okay, and that is basically your final answer for question 3.4.4. All right, and all right, and then that is it. We are done with question 3, guys. Right, I hope I managed to explain all those concepts for you guys in a way that is clear for you guys to understand. Okay, so now we're going to be looking at question number 4.
That is it, guys, and I'll see you guys on my next upload, Distance Learning with Lee, where I make learning mathematics super easy. Bye, guys.